Dear students, in this video we are going to see the experiment number 1, that is exploratory data analysis and data pre-processing for the course 20CS2032L Machine Learning Techniques Lab. I hope that you have already completed the course Introduction to Data Science, where you have know the basic ideas of how to handle the data and what are the various types of data and what are the various insights you can derive from the data and various basic machine learning techniques we can use it to work with that particular data. And to start with this experiment, we divide that experiment into two parts. That is, experiment number 1, A part, we are going to see the exploratory data analysis. And in this exploratory data analysis, what are the steps we are going to do? First, we have to import the necessary libraries, then read the data and know the characteristics of the data. That is the analysis we are going to do in terms of outlier analysis, correlation analysis, and the univariate, bivariate and multivariate analysis. So to start with the experiment, first we have to know what is an exploratory data analysis. In a data science process, after gathering the data you need to analyze the data to identify some common patterns, and also you have to derive the insights about the data before using the data to develop any machine learning model. So data exploration and analysis is one of the important part before any machine learning model implementation. So first, to support this exploratory data analysis, these are some of the Python libraries. Basically, we can use it in the machine learning. So NumPy library mainly used to handle with the mathematical functions of multidimensional arrays, and SciPy, which is used for optimization, statistics, and all the modules are integrated in the SciPy library. Then scikit-learn, which will show with the classical machine learning algorithms are available in the scikit-learn library. Then pandas, mainly used for the data extraction and the preparation, and matplotlib used for the data visualization. And to extend with, we have the other Python libraries, that is Theano, TensorFlow, Keras, PyTorch, that will support the high level of machine learning algorithms. And next step, we have to read the data. So while we read the data whatever we are reading, either it is read from the Excel file or it can be read from the CSV file. The data whatever we read from this file will be handled in the form of data frame. So pandas will handle this data frame. The data frame is nothing but a two-dimensional data structure where the data are arranged in row-wise and column-wise. So the row-wise are called as your records or instance, and the column-wise you have all the features that represent the particular instance. So here I am going to work with the sample CSV file called as iris.csv file, which contain the information about the flowers, and based on the categorical representation what type of flower it is. So based on the petal width and petal length, and then it have the sepal width and sepal length, and use these as an input features, and it is specified with what type of species it is, the type of the particular iris flower. And to start with, I can either use datalab.carnia.edu or you can use with the Google Colab. So first step is you have to import the necessary library. That is, here we are going to use with the pandas library. So import the library, followed by read the CSV file. So to read the data, so we have to use the pd.read_csv, pd.read_csv. The file name I have to use it here is iris.csv. So this I am going to store it in a variable that I am considering as a df, data frame. So after reading the data, Now we are entering into the exploratory data analysis to mainly discover the patterns and also to spot the anomalies and to test the hypothesis and to represent the data in terms of statistics and the graphical representation. So mainly we are analyzing the patterns available in the data and also we are deriving some insights from the data. So EDA is the prior step in any machine learning model, because before using the data to the machine learning model, it is a good practice that first you have to understand the data and try to get some insights from the data, because you need to detect the outliers and detect the anomalies and missing values, and you need to maintain an analysis like univariate analysis, which data is correlated with which data. So all those things you have to analyze. And we know some basic Python functions which will help you to get the information about the data frame. So we are getting the outputs from these functions directly. But in this experiment, we need to use these functions to derive some insights from it. Okay. So for example, so I told already I have 4 input features. So these are my input features. And this is also one of my input, and I have my output feature is species. Species specify my categorical value that specify what type of data it is. Okay. So now from this data, so the info generally shows the columns and their corresponding data type, whether it contains null values or not. So as for the details from here, I know that this column having a null value. And also I know that out of these 6 columns, this one, the first 4 are of integer type, that is a numerical data type. And so I can tell it is a numerical type. And the last 2 are the categorical type. So by using the info, I am getting the overall information. So now I want to extract which are the columns are having the numerical value. So I want to extract. So you need to hard code the Python coding to derive the particular columns which are all of numerical data type. So to do that, I think you know the function called as select underscore d types. Okay, select the data types if the data type is number. Okay, so if the data type is number, that columns, okay, that columns you can take as a output. So the columns, so whatever columns which having a number data type, that you will get it. And from that, all the 4 columns will come. So I want to know how many number of columns having the numerical data type. So you know with the function length. So if I put this column, so I can, so by using that output of a predefined function, I want to derive some insights out of that. So this will return you number of numerical columns. Okay. So now I want to identify which column having a null value. So from info also I know that this petal length column having the null value, and by using is null of dot sum also I know that, but I want to display only the column name which containing the null values in that particular column. So to do that, what I have to do again, so you have to specify, or first I have 5 columns, so you know that you need to use with the for loop. So for I in df dot columns, so from that column, each column I get from I, and I know that I need to check if the columns is null dot sum having a value or not. So I need to use with the df, the first column I take, and I am going to check whether it having is null dot sum. So the first column I will take, I am using with is null of sum, so it is 0, so nothing get displayed, that is false, but only this I have a true value. So if I try to display I, so it will tell me the column this having the corresponding null value. And also I want to use, I have a function called as describe. So basically you know that the describe function give the summary statics of the particular data set. So this will work only for the, defaultly it will work for the numerical column. So now I need to take, so this will give the entire description. So from that I want to take only the columns mean values alone. Okay. So for that what you have to do? So I need to use with describe. So describe will return all the things. So from that I need to take only the mean value. Okay. So only I need to take the mean. So it will return back the mean value of the all numerical column. So I am trying to extract a specific insight out of the entire information by writing some specific code by backend using the default Python functions. And now we are moving to the EDA. So EDA, we are going to perform three types of analysis. The first one is the outlier analysis, second one is correlation analysis, and the third one is univariate, bivariate and multivariate analysis. So first you have to know what is an outlier. So outlier is generally an extreme value or abnormal value along that contained in your data. So if you see here, so these are all some group of data. So from that I have some extreme values. Okay, so if I consider this column, so generally the range of values coming from 1.1 to 1.4 to 1.7. But I have some outlier 8.3 and then 6.4 and 5.5. So these are some of the outliers which is not available in the normal range. So generally this outlier will affect the performance of your machine learning model. So you need to identify this outlier and it has to be removed while you do with the pre-processing. So using this exploratory data analysis, by seeing the data or by inferring the pattern of the data, we can able to identify which are all the columns having the outliers. So the outliers can be identified by checking the mean value is less than the median value, or if there is a large difference between the 75th quartile and the maximum value of that particular column, or you can use the concept called as IQR, interquartile range. In that we have a lower value. The lower value is represented with the boundary value is Q1 1.5 into IQR, and here Q3 plus 1.5 into IQR. So whatever values goes beyond this, so that will be considered as an outlier. And by using the visual representation as box plot also, you can identify the outliers available in the data. And by calculating the z-score for every instance also, you can able to identify if the z-score value is greater than 3, that particular instance is an outlier. So as you know already, the describe function will display the entire information about the data set. So now you know that the petal length column only have the outlier. As I said, the first thing, so your mean value is less than the median value. The 50% is generally represented as a median. So the mean value is less than the median value. So automatically you can tell that this column having an outlier. And then the next thing, the 70, there is a large variation between the 75% and the maximum value. If you see here and all, the variation is almost 1, difference is 1, but here the variation is very large. So this is the second case you can use by identifying the outlier. And you can do with the box plot for the particular column. So if I do the box plot, so when I use with the box plot, so this will be called as your maximum value, this will be your minimum value, and this is the Q1, and this is the Q2, and this is the Q3. So whatever lies above this max value, so here in max also I can use with the IQR, that is the interquartile range. I can put the boundary. Between that boundary, whatever values comes, that will be the normal value. If it goes beyond that, so this is your outlier. And next, how to calculate this quartile value. So what is mean by quartile? So if you given a data, okay, so that data will be splitted into 4 equal slice parts. So that is called as quarter. So if I have a input data like this, so this will be divided into 4 parts. So in order to do that, the first step is you have to order the data. After ordering the data, you need to find out the cut points. Okay. So the cut points, how to calculate the cut points? So we need to calculate 3 cut points. The first cut point is at the 25%. That is the 25% or quartile, first quartile, or 50 percentile, that is the second quartile, and 75%, that is the third quartile. So how to calculate the cut point? The cut point, the formula is P divided by 100 into n plus 1. So n represents the number of data points. So based on here, I need to calculate the 25% cut point. So apply the formula 2.5. So I need to put a cut between the data point 2 and 3. So this is my cut point. And I need to calculate what is the corresponding value of Q1 in that particular cut point. That is, the Q1 will be lies in between the datas 2 and 3. So to calculate the Q1, you need to take the value of the data 2, the value of the data 3, add together, divide by 2. So the average is 28. So it represents 25% of the datas or below the value 28. So like that, you need to calculate Q2 and Q3. That represents 25 percentile, 50th percentile and 75th percentile. So using these 3 informations, you can easily develop your box plot. So the box plot, this process is actually called as 5-number summary. So you know what is the minimum value, you know what is the maximum value, and you know what is the value of Q1, what is the value of Q2, what is the value of Q3. So 5-number summary. So the representation you represent in terms of the visualization is the box plot. So as you see here, this is the corresponding box plot, and interquartile range will be calculated by Q3 minus Q1. So all your data values whichever lies between the lower range of Q1 minus 1.5 into IQR and the upper limit Q3 plus 1.5 into IQR, all values in between from this lower limit to upper limit, all values in between will be considered as a good value. So if any values that goes beyond of lower or the upper limit, so that will be considered as a outlier. So if a data is given, a particular column is given, you are expected to calculate what is the Q1 value, what is the Q3 value, and calculate what is mean by IQR, and you just check whether all your values are lies between this lower limit and upper limit, and based on that you identify which data points are normal data points, which data points are outlier data points. And there is another way you can perform or identify the outlier, that is the method called as Z-score. So for this column you want to identify or you want to do the analysis of outlier. So what you have to do? You have to calculate the mean. So how to calculate the mean for the corresponding column? You specify df, the column name dot mean. So it will return the mean value. Like that you need to calculate the standard deviation. So after calculating the both things, for every value in your data, you need to calculate 1.4 minus the calculated mean value divided by standard deviation. If the value what you get is less than 3, then no problem, it is not an outlier. So but if you see here, it will give the outlier value greater than 3. Okay, so this value becomes greater than 3. So automatically, so if you have any values greater than 3, so automatically you can specify this value is an outlier. So this will get the Z-score value is greater than 3. So if you get the Z score is greater than 3, automatically this data point is an outlier. So basically you see here, so between the plus to 1 plus or minus 1 deviation, you have 34% of data will be allotted there. And between plus or minus 2 standard deviation, you have around the data are 68% data. And between plus to minus 3 standard deviation, you have 99.7 data are normally distributed. So whatever data that is go beyond greater than 3, so that will be considered as an outlier. And the next type of analysis called as correlation analysis. So correlation analysis mainly used to identify the linear relationship between two variables, and it also specifies how much it is associated, whether it is positively correlated, negatively correlated, or no correlation. So that information, how much one variable affect the another variable, that correlation value you can identify using the correlation analysis. So if two variables, okay, so I will consider two features. The two features are highly correlated, okay, the two features are highly correlated. Then out of these two features, I can select any one. Okay, so instead of using two features in machine learning training, so I can skip or I can drop any one of the features and select only one. Because from these two, any one will, so both are highly correlated because change in one feature provide the change in the another feature. That is a positive correlation. So if two features are highly correlated, you can specify or you can drop one of the features from it, and one feature you can consider for the thing. So out of these two, which one need to be selected, that you have to identify whether F1 is mostly giving contribution to target or F2 is mostly giving a contribution to the target. So out of these two, who is giving more contribution to the target, that you will select. The other one you can drop it. So if there is no correlation with the data, that data is also you can drop it safely. Basically the correlation will be calculated by using a Pearson correlation coefficient or Spearman correlation coefficient. To do this in Python, we have a built-in function called as correlation function. So this function used to identify the correlation between all your numerical columns. All your numerical columns, it will provide the correlation. To visualize this correlation, you have a function called as heat map, which is available in the Seaborn library. By using heat map, you can display that thing in a visual representation. So correlation function will display the correlation like a matrix, the numerical values. So that will be represented in a visual format. Okay, so this is the example of the correlation matrix. So this correlation specifies, so it will provide the correlation between all numerical values. So how the fixed acid is correlated with the citric acid. So here this will be the correlation of same. Okay, the diagonal specify the correlation between the same features, and the other things are the correlation with the another features. So here the dark color represents the high correlation and the light color represents the low correlation. But here if you see, here you have only the colors representation. So if I want to give the corresponding values, you need to put are not equal to true, so that you will get the corresponding values of the correlation matrix, which is embedded inside the heat map. So if you see here, for all the diagonal, because it is correlated to the same input feature to the output feature, so it is the correlation value is 1. And if you take here the dark value, okay, the dark value, it is a negative correlation. This is negative correlation, highly negative correlation. And then you have the 0.84, which is highly positive correlation. Okay, so as outcome from the correlation matrix, from the heat map, you have some numerical values. So now you want to derive some insight from it. So I need to derive what is the features which is highly positively correlated. So how to identify that? So you need to write a Python code from this correlation matrix. You have to take every column and you need to identify what is the maximum positive correlation except one. Okay, that you need to identify, and for that you need to display the corresponding row name and the column name. So here if you take the residual sugar and the density having the high positive correlation. Who is having the high negative correlation? The density and the alcohol having the high negative correlation. So how to identify it? I will just give a gist, so you just develop the code out of that. So to take the corresponding value, I need to go with, it's like a two-dimensional array. So I need to take the column, that is the first index, I index. So that I am taking from my correlation matrix. Same thing, I need to take the jth, that is jth index, that is also from my correlation matrix. So from that I can able to know the corresponding values of the column 1 and the column 2. So I need to write a condition. If my value whatever I got is the maximum except 1. So this value should be maximum but not 1. So I write a logic by using a if condition, and I need to display which corresponding row wise and column wise feature that provide the high correlation. Like that I need to identify which row wise and column wise feature, which two features are highly negatively correlated. So like that you have to write the code and identify. And then you need to identify which is the you need to identify the features which having greater than 70% of the correlation. So if you see here it is 40%, here it is 9%. So I need to identify which two features are having the correlations greater than 70%. So I can take this as 84, and then I can go here, this is 78%. So this will display 78%, 84%. So whatever correlation which is greater than 70, I need to calculate. Either it can be a positive or it can be a negative. So the same procedure I have to follow. I need to take the I index, that is the column 1, and then I need to take the J index, that is column 2. Then for every value, okay, so from the correlation matrix, the particular value I take it, and then I need to convert that into 100, and before that I need to consider both positive and negative. So I just keep it is an absolute. So I calculate the value of every cell, okay, every cell, and I need to identify if the value is greater than 0 or greater than 70%, that columns I need to display. So which are all the features having the correlation that is greater than 70%. Again the constraint, not take 100%, because the diagonal values will give the 100%. Or don't consider the correlations of above 70% but less than 100%. So you have to hard code it from the correlation matrix. You need to retrieve that insights. Now we are moving to the next thing, that is the distribution. So how the data are distributed. Generally the data are distributed in a positive distribution, negative distribution and the normal distribution. Okay, so the dist plot will help you to specify how your data are linearly distributed, or it represents the skewness of your data. So since you know it is positive skew, negative skew and the zero skew. Okay, so the kernel distribution or kernel density estimate tells how your data are normally distributed. The shape of your data's distribution will be given by the dist plot. So here you see here, when I use the dist plot, it specify it is positively skewed. In the positive side it is skewed. It is skewed. And here the negative side it is skewed. And this is a normal distribution. So both sides the data is equally distributed. So how can I find out the skewness? So to find the skewness, so you need to use the column name then you have a function called as skew. Okay, so I can find out the skew value like this. So if it is positive, it is a positive skewness. If it is negative, it is a negative skewness. So apart from doing that, I need to do the calculation. So I need to calculate the mean of that particular column, and then I need to calculate median of the particular column, and then mode of the particular column. So if I take this, the mean value is greater than the median value, then automatically it is a positive skewness. So here mean is greater than the median. Here mean is less than the median, so automatically it is a negative skew. So you need to calculate the mean of the particular column, median of the particular column. You need to identify whether the mean is greater than median or the mean is less than median. Okay, so by using that, you need to tell whether it is a positive skew distribution or the negative skew distribution. And the next analysis we need to do with the EDA is the univariate, bivariate and multivariate analysis. What is it? Univariate means you are considering only one column, that is only one variable from your input you are considering and analyzing that. Bivariate means by comparing two features. Okay, so you have several inputs. From that, what is the correlation between two inputs, two input variables, that you have to find out the relationship. Multivariate means comparing more than variables and identifying the relationship between them. So first we have to go with the univariate. So basically the univariate analysis can be done in two ways, that is the central tendency, that is mean, median, mode, and dispersion. There you consider the range value, maximum, minimum, your IQR, standard deviation, everything. So this already you have done with your data science. You have analyzed the central tendency and the dispersion measures of a particular column. And now the data can be either a categorical data or it can be a continuous data. So when I consider a particular column, if the categorical data, if it is a categorical data, I can use the univariate analysis using the graphical representation such as bar plot and pie plot. If the data is a continuous data, then you can go with scatter plot, swarm plot, histogram plot or the biline plot. So bar plot, for example, in my data, species is the categorical data which contain three types of labels. That is, it having three categories, category 1, category 2, category 3. Okay, so I may have 1,550 data. So out of that, I have the class C1 is of 50 data, class C2 of 50 data and class 3 of 50 data. Okay, so I am taking only one categorical column and I need to do the univariate analysis using the bar plot. So I do with the bar plot. Category 1, what is the count? Okay, count is 50. Category 2, what is the count? Category 3, what is the count? So in order to do that, I can just write a function, that is, so I need to put df species dot value counts plot dot bar. So this will create a bar plot based on the categorical value. So like that you can create your pie plot also. Instead of bar plot, you can give it the pie plot. So pie plot also, you know that it is slices divided into 3 or 4 parts. So depends on, here it is. So 50%, 50%, 50%. So that is not 50%. So out of 50, so this is 50 data points, 50 data points and 50 data points. And if your data is a continuous data, then you can go with scatter plot, swarm plot, histogram. Basically, you know with scatter and the histogram. So bar plot is the count things. Histogram, you have the x-axis is the range. So range value and you represent with bins. So that is your histogram plot. And scatter plot, so it is again a one-dimensional value. I will take with only the column sepal width. So sepal width is my input, that is a numerical value. So how to find out the scatter plot? The scatter plot here it represents the index value, and for the first index what is the sepal width? For the second index, that is your instance, second instance, what is the value? So your y-axis represents the sepal width. So using the, in your C bond S and S, you have the scatter plot. So you use with the scatter plot. X will be the index and Y will be the corresponding numerical column you give. So you will get your scatter plot. And now we have the next type of plot is called a swarm plot. Okay, the swarm plot, the x-axis represents the sepal width and the y-axis represents how many instances having the value 2. So out of the data, the sepal width 2, I have 1 value. The sepal width 2.3, I have 3 values. Sepal width 2.5, I have some 8 values. So that you represent with the sepal, represent with the swarm plot. The same swarm plot, I can group it based on color. Okay, so out of this whole sepal width, some of them belongs to category 1, some of them belong to category 2, some of them belong to category 3. So this can be represented like this: SNS dot swarm plot. In that my x value represents df of sepal width. Okay, so this will represent the first graph. Suppose I need to represent with different color with different categories, then I can use another property called as hue. In the hue, I have to represent df of the species, the category I apply. So from the sepal width, based on the category, I can have it. So from setosa, the minimum value of sepal width, I have some 2.3, and the maximum value I have some 4.4. Okay, so I can infer something. So if the particular flower type is versicolor, and then the minimum value of the sepal width is some 3.4. Maximum value is 3.4 and the minimum value is 2. But it is a setosa, the minimum value is some 2.8 or 9 and the maximum value is 4.4. So like that you can derive some insights from this graphical representation. The same thing you can go with the next type of plot is called as violin plot. This is almost giving a representation of your box plot. So you have the median value, then you have the upper level, lower level and interquartile range. So all those information. So when I give this orient equal to vertical, then it will be displayed like this. And here also when I use with Q, so for each category I will get different colors. And the next type of analysis is the bivariate and multivariate analysis. In bivariate, I will consider two sets of variable. So in one set, the x-axis also continuous variable, y-axis also continuous variable. That we have already seen with our correlation or heat map. So one numerical value, how it will be positively or negatively affect the another variable, the correlation. And also you can use this scatter plot also, provide the relationship between the two continuous variable. And the next type is you have your categorical variable here and then your continuous variable here. That will be represented your bar plot and the box plot. And between two categorical variables, so that I can have the categorical variable here and I have a count in the left side, that is my y-axis. So I can use with a plot called as count plot or the cross tab representation. And the last one, multivariate analysis. So it provide the analysis or it provide the relationship between more than one variable. All variable, it provide the how it is related with another. So it is providing a pairwise plot. And now it is a categorical plot. So first is the categorical plot of type is, you have the, so this thing you know with scatter plot. So for example, so if I increase the price, how it increase the maintenance. Okay, so if it is positively incrementing, so the points how the price will affect the maintenance. So I can scatter the x-axis also I have a continuous variable, y-axis also I have a continuous variable. And then categorical, so in that also I have SNS cat plot. Okay, so cat plot in the x-axis I have to give what category, that is here it is my species. And in the y-axis I have to give the sepal width. Okay, so sepal width, df of sepal width. Okay, and the type I have to specify, it is a bar plot. If I want to specify box, it becomes box. If I specify violin, it becomes the violin plot. Okay, and here the y value, what it represents. So out of this all iris setosa type, what is the mean value of sepal width? So that will be given here. So that represents the mean value of that particular group. Okay, and now I want to specify with more than one categorical variable. So that time you need to specify the same thing, x is there, y is there, and along with that I have to specify the hue. So hue represents my color. So in iris setosa, how many are yellow color, how many are green color? Again, within this category I have another one category. Okay, so that you can do with x, y and the hue. And next we move to the count plot. So count plot is plot between your between two categorical variables, and in that the x-axis represents category, y-axis represents the count. So I have two categorical variable. First one is the species, and this one is species, and this one is color. So in this group, in this categorical, how many are of type yellow, how many are type green, and in this categorical variable, how many are with the green color and how many are with the red color. So this is the bivariate analysis between two categorical variable. That can be represented by means of the cross tab also. In iris setosa, how many are used with the green color and the yellow color. And here how many are with the green or red. So there is no yellow color in the type of green virginica. So that represents the cross tab, that is the correlation between two categorical variables. And the last one is pair plot. Okay, so pair plot is mainly provide a pairwise correlation between numerical values or continuous values. So if you take here, this is the correlation between sepal length and the correlation between sepal length and the petal width. And this is the correlation between sepal length and the petal length. And this is the correlation between sepal length and the sepal width. Again, it is the flip. The top upper triangle is the flip of the lower triangle. So the same things only we are getting here. That here the correlation between petal length to the sepal length and the petal length to the sepal width. Okay, so the x and y will be just translated in the left upper triangle and the lower upper triangle. So here this is the distribution between the same pair, sepal width to the particular sepal width. The pair between the same data types or same variable, and that remaining represents the pair between the other things. So we can represent with SNS dot pair plot data equal to df and hue is equal to df of species. So based on the categorical value, I have to give the color. So this is the overall thing about your first lab experiment. So basically you can solve these all questions. You can read the data. Then by using the tail and the first, you can display the first 5 rows, last 5 rows, and you can display the number of rows and the columns available in your data frame. And this only I told, when I use with describe, it will tell the overall information. But I want to extract only how many categorical column is there, how many numerical column is there. And again, you have your describe function which will display the entire information of your mean, median, maximum, 75%, 25%. So you have to extract only the specific values. And your is null will return the null values, but you need to display the columns with only the null values. So you need to hard code how to calculate the 5-number summary for a given thing, and you have to correlate it with the box plot. And you need to identify your outliers by calculating the Z score for every value. And since you know the correlation matrix will give the correlation value, so from that you need to hard code the Python code and to identify which is the highly positive correlation and which is the highly negative correlation. And by using the same correlation matrix, you need to identify what are all the features having the correlation that is greater than 70%. And you need to perform the plot to show the distribution of your data, followed by your data is right skew, left skew or no skew. And this will help you how to identify the univariate analysis for the categorical variable, univariate analysis for the continuous variable, and then you need to provide the bivariate analysis of the two continuous variable, bivariate analysis between continuous variable and the categorical variable, bivariate analysis between two categorical variable, and finally you need to use with the multivariate analysis using the pair plot. Thank you. So you can make use of this description and start to do your first lab experiment.